We all know how three-dimensional oranges are stacked in grocery stores. But what do you think the best way
So, when are you going to do that?
to stack 100-dimensional oranges is?
Make sure you do that tomorrow because you only have 2 days left.
Infinite series.
So, yeah, you have tomorrow and Friday to get that information.
Infinite series. A new PBS digital show about mathematics.
That's fine. I would like you to...
The study of math is old. Really old. But right now it's expanding faster than ever.
And if you want, you can go get the Sharpies down for my car.
Each plink will explore a new corner
Art supplies, you can use those.
of this puzzling universe that's being carved out
Design, maybe a title.
by mathematicians right now.
Alright,
For today, it's hyperspheres. What the heck are those? Well, it's a sphere in dimensions that are bigger than 3. And while stacking hyperspheres has surprisingly practical applications in error-correcting codes to ensure accuracy when transmitting data like through cell phones, the sound lights, and I want to talk about them because they're cool. Their properties are counterintuitive, and even seemingly simple questions about hyperspheres are very, very, very hard to. But before we get there, let's start with spheres. It's easy to define a sphere in any dimension. It's all the points that are a fixed distance away from a central point. In a two-dimensional plane, you can imagine holding a rod fixed at one, wanting the other to trace out a circle. In 3 dimensions, the same trick works, but now it has more freedom to move and traces out a sphere. In higher dimensions, this traces out a hypersphere. So what does that look like? Well, before we get there, let's start talking about what mathematics mean when they say higher dimension. We can visualize one dimension as a line. But another way to think about it is all the points described by one coordinate, which we usually call x. 2 dimensions is just all the points described by 2 coordinates. We call them x and y. 3 dimensions is just 3 coordinates. That means it takes 3 numbers to describe a point in 3-dimensional space. 2 numbers alone isn't enough to give direction to a specific point in 3-dimensional space. Even though you can't really visualize it, 4-dimensional space is just a point specified by 4 coordinates. 8-dimensional space is just 8 coordinates. Mathematicians had wondered this for centuries about the optimal way to fill space with equally sized, non-overlapping spheres, known as sphere packing. You can try the 2-dimensional version at home. How should you arrange pennies on a table so that you have the least amount of table showing between the pennies? At best, you can cover about 91% of the table. What about in 3 dimensions? Way back in 1611, famous James Kepler guessed that the best way to pack 3-dimensional spheres are this and this. These sphere arrangements are intuitive. It's how tennis ball oranges are often stacked in stores. They waste the least amount of space between balls, filling about 74% of total space. Kepler was right, but it took nearly 400 years. Mathematician Thomas fails to actually prove his conjecture. But what about sphere having a higher dimensional space? Spheres are less intuitive. Mathematicians have struggled to prove anything about sphere packing dimensions bigger than. However, just a few months ago in March 2016, mathematician Marianne Williams proved the best pack spheres in 8 and 24 dimensions. The standard way to pack spheres in 3 dimensions, and now along in higher dimensions, the spheres move further away from each other as dimension increase. Then something special happens in 8 dimensions. 8 dimensions, there are exact room between the spheres to squeeze a new one. For details of I got the quadra article in the description. Now here's the totally wild part. Mathematicians don't know the best strategy for packing spheres any other dimension. You know the best arrangements in 2, 3, 8, and 24. That's it. We are just our premium sterling hyperspheres. Per white sphere packing higher dimensions is so technical at hyperspheres are basic possible to visualize. People has used visions of higher dimensional spheres, particularly 4-dimensional. Think about it this way: push a 3-dimensional ball through a 2-dimensional surface like a tape. Portion of the ball would be intersecting the surface would always look like a disc. First tiny disc getting bigger, then getting smaller again. This two sides of the ball. If we remember took the 4-dimensional push through 3-dimensional, we'd see 3-dimensional. This time getting in the form. These are 3D slices from the ball. Dimension are visualized. Cream to use spots to show we are a sphere. First half is their cube. To just fragment. Nothing range is there touch the kite. The school sometimes on the spare. This don't take the two and keep environments. Side and cube some like bleachers and songs. The dimension is printed. The cube occupies wet sphere. Finger. And 3 inches are looking at a team. Is a cube sign. Without big stand. Relative to Sportia. Where just save me. Shorns there. On land. I have a light. Course, circle these 4 boxes. Another, and then next to spare tugs other circles. Those black circle is far inside the box. Now let's try the whole thing in 3D. Some cube and some apex or octets. So there's sphere so it perfectly nestles inside each octet. There's draw a sphere that just touches the other 8 spheres. And again, the sphere is way inside the cube, in higher dimensions. Nestling to the end, the outside spheres. An n-dimensional cube, it's a central sphere that touches the others. As the dimensions goes up. But here's the totally mind-blowing part. At 9, the sphere actually bursts through the sides of the box. Why is this happening? Well, roughly because as the dimension goes up, the distance from the cube and the dial distance gets longer and longer. See, higher spheres are so many counterintuitive. That is so awesome. The cool way of visualizing hyperspheres. Let us know in comments. And see on Infinite Series is Infinite Series.